Were you guys introduced to metric in middle school at some point? Yes? They probably gave you a lot of different prefixes that you had to know to convert between. Does that seem reasonable to say? We don't want to make you memorize a whole bunch of stuff that you're not going to use. So instead, in chemistry, we narrow it down to only the prefixes in metric that you need to be aware of. For example, milli is one that we use. You just did milliliters a little while ago. Millimeters is another one. So milli is a prefix we're going to need to know. You did centimeters. Centi is one that you need to know. Sometimes we have a large amount of something, though, and we have to do kilo. Now, that one you should be aware of. The last one, there's only 4 prefixes that we ask that you actually know, is the one that might be a little more unfamiliar to you. And that's going to be nano. Maybe you've heard the term nanotechnology. I mean, really tiny stuff gets measured in nano. We can even go smaller than that and do pico, which we will reference a little bit, but we don't require that you do any calculations with. On this how-to sheet for conversions, a conversion is kind of an equality. So for example, there is 1,000 millimeters in 1 meter. Now the beauty of metric, and we'll go over this a little bit more later, is I could replace the meter base unit with liters. There's 1,000 milliliters in 1 liter. There's 1,000 milligrams in 1 gram. We can do units that you're not even aware of. There's 1,000 millimolar in 1 molar. There's 1,000 millijoules in 1 joule. There's a lot of base units that we do use in chemistry, some more than others. But let's stick with meter for right now, your unit of distance. I'm hoping a lot of you remember centi is 100. Just like there's 100 years in a century, there's 100 centimeters in a meter. 1,000 years, millennium, 1,000 milli. Kilo, however, is the bigger of the units. So there's actually 1,000 meters in 1 kilometer. A meter stick, thing that's underneath your lab drawer, is what we kind of think about for the size of a meter. A kilometer, sorry, I should put the 1 in front of it. There's no roughly a mile, not quite, but at the same time, it's a good way to kind of visualize. Meters like a yard. You need a lot of yards to make a mile. You need a lot of meters to make a kilometer. Lastly, nano. There's 1 times 10 to the 9th nanometers in 1 meter, which means a nanometer is really tiny. We will use that for measuring light and the wavelengths of light, which we have to go over in Unit 2. So Unit 1, we have to address this unit in order to use it in Unit 2 calculations, which we will use. These are all equalities. Just like 3 feet is 1 yard, 3 feet is 36 inches, we need to be able to convert from one to another. And when you look at this how-to sheet, it says underneath that first paragraph, your basic setup, the number you want to convert, times, and then you do a conversion factor. On the top of that conversion factor is what you want to get to for a unit. On the bottom is the unit you want to change. And then they show you an example problem as well. I'm going to go down to question number 1 at the bottom of the page. I'm going to go over a couple of conversions with you, then give you a few minutes to try some on your own. And then we're going to start going over scientific notation and then combine the two. So question 1 says, if I walk 1,765 meters, how many centimeters have I walked? Whenever you guys do a conversion, my first suggestion is just write down the number given to you. Don't even think about it too much. Just write down that number. Now go back and look at the question to determine what are you trying to solve for. This particular question is having you solve for centimeters. I usually like to use parentheses, but if you don't want to, that's okay. It's still, we should set up a conversion factor. My unit on the top of a conversion should be what I'm trying to solve for, the centimeters. On the bottom is the unit that I have, meters. And hopefully there's been a math class that's kind of taught this to you. But if I have the exact same thing on the top as I do on the bottom, the two cancel each other out. You don't have to actually do that crossing out if you don't want to. I'm just showing you then that your final answer will be in centimeters. However, a conversion needs to be an equality. The thing on the top has to equal the thing on the bottom. And that's where I know there's 100 centimeters in 1 meter. Once you set up your conversion factor, you solve. For some students, they can multiply by 100 in their head. For some students, they're going to move the decimal because that's what they've been taught. I'm fine with that. Some students actually type it into their calculator. However you want to do this, 176500 centimeters would be your answer to this first one. Since the number is in the numerator, the top of the conversion factor, you multiply. Please, don't actually type in your calculator divide by 1. If you need to know what any number is divided by 1, let me know. Smack some sense into you, and you realize you're just wasting your time. Any number divided by 1 is that exact same number. Just like if we were to flip this, don't ever multiply by 1. Because what's going to happen when we get to difficult conversions, order of operations is going to start to creep in. And it's going to throw off everything that you do if you decide to be a person that types in times 1. And now your calculator is going to do order of operations differently than you intended, and you're going to get the wrong answer. So only worry about the non-1 number. If I look at letter A, it asks how many kilometers have I walked? 1,765 meters is my original starting value. I want to solve for kilometers. So that unit goes on the top. What you want to solve for goes on the top. Again, if you are someone who can look at this problem and just move a decimal, I'm happy for you. But we got to get used to this mindset of how to set up a conversion. On the bottom is the unit that you had to begin with, so it cancels out. You're going to find second semester that unit isn't even a measurement sometimes. It's an actual thing. You can convert from one chemical compound to another chemical compound using conversions in a balanced equation. Now you have to put in the equality, and that's where I had, again, these equalities listed up on the board before. There's 1,000 meters and 1 kilometer. So here, my meters cancel out. My final unit would be kilometers. I recognize that I'm not going to multiply by 1, because I know that's just going to give me the same value. So I'm going to take my 1,765 and divide it by 1,000. And this is where, use that metric for those of you who are strong with that. 1.765 kilometers. Move your decimal at that point, that's fine. But we require that you set up the conversion. When you do a problem like this on a quiz or a test, we grade the conversion. So this is not a 1-point math problem, this is a 2-point problem. 1 point is for the conversion, 1 point is for the final answer. You forget a unit, that's going to cost you 1/4 of a point. Later when we do more complicated things, we have to go over how to round off your answers. That'll cost you 1/4 of a point. If I do the last one on this page, it asks how many millimeters have I walked? And if I start back with the original 1,765 meters, notice how I do all these problems. I don't fill in the numbers first. I figure out the units. Because I know down the road, that's going to do you good. Too often students try to do the entire thing at once. Maybe again because metric's easy for them, they want to do it that way. But if you first put down the units and then figure out what numbers make that equal, this is going to be helpful when we get to more complicated conversions. I multiply by 1,000 here. 1,765,000 millimeters. Now, if you flip to the back side, there's a couple of problems that change the base unit from meters to grams, or from meters to liters. Let's have you, on your own, spend the next 3 or 4 minutes trying to do a few of those problems, and then we're going to start to introduce scientific notation, And towards the end of the hour, you'll work with each other or on your own because we're going to put the two together for some problems as well. Okay? Okay, what I want to wrap up this first batch of metric with before we move on. We could give you a problem like this that I have up on the smartboard. I've given you a measurement, and again, I'm not writing the entire thing out. 475 millimeters, I want you to solve for kilometers. So I'm going to write down what I'm given. What makes this problem a little bit different is that we are not asking you to solve for just meters, which is the base unit. Or we didn't start with meters, the base unit. We're giving you something with a prefix and something else with a prefix. Now, I know that some of you might be able to combine two conversions into one. And actually, if you did that and showed your work, I would accept that. However, you are going to be faced with a lot of multiple step conversions in this class throughout the course of the year. And what we suggest is doing one step at a time. So if in this question, which if you want to follow along, there's space at the bottom of your page, you could do that there. In this question, if I wanted to solve for the kilometers, I would first realize I need to get to the base unit of meters from millimeters. How are those two related? There's 1 meter for every 1,000 millimeters. So in other words, I'm dividing by 1,000. If I do that, I'd get 0.475, meters. But the question isn't asking for meters, it's asking for kilometers. So I'd have to do a second conversion. And this is something that we do a lot of in this class. And I tell you right now, on any assessment, quiz or test that we give, we try to vary the level of difficulty. Because if I made every question easy, then everyone would get an A in this class, and I really don't know where everyone stands. If we made every question difficult, we don't really know where everyone stands. So there's going to be some metric conversions that are one step and done. There's going to be some that are multiple step as well. So we want you to get used to doing both. In this question, I wanted to solve for kilometers, so kilometers is on the top. Meters is on the bottom because that's the unit I currently have. How are they related? There's 1 kilometer for every 1,000 millimeters. So I need to divide by 1,000. If you were someone who used your calculator, you would get two possible ways that this would be expressed. 0.000475, or they might call it 4.75 times 10 to the negative fourth, which is in scientific notation, which is something we have to remind you of here in a couple of minutes. I honestly don't actually set it up like this. I'll show you what I do instead. I do my first conversion, then I immediately go to my second conversion. And then I only do one calculation at the end. I set it up this way because I'm used to doing multiple conversions in other than powers of 10. And because of that, I want to get all my work shown and then I just type it in all at once. Remember, if the numbers other than 1 are in the denominator, you divide. If it's in the numerator, you multiply. But not only one-step metric, two-step metrics we have to know. And as you can see on the answer for this, scientific notation is something we have to go over here as well. Okay? So that's what I'd like us to have out now is that scientific notation sheet. When we go back to my final answer on that last question, my power of 10 was to the negative fourth power. That shows that that's a decimal value, a tiny number. If, on the other hand, that was a positive 4, that would be a big value. When you look at the how-to sheet, you can see examples of both on the top there. 4.32 times 10 to the 22nd. That means 432 with 20 zeros after it. We'll be working with numbers bigger than that this year. 7.8 times 10 to the negative 8. That's a tiny number. That's a decimal, 7 zeros, and then a 7. And the last way I have shown is what your calculator will often do. It'll use the letter E to show times 10 to whatever power. It's actually even a button on your calculator that you might want to get used to using. It's either the E or the EE button. So there are different ways that this can be expressed. If you look at the middle of this worksheet, it starts off with a problem that has this written down, and it asks you to write it in scientific notation. And the second question has 7, 3, 4, 2. That. We are not going to, in any sort of true assessment that you're graded on accuracy, ask you to take a number that's in scientific notation and convert it out of it, or vice versa, like I'm asking you to do right now. But I want to quickly go over this to remind you of what scientific notation means. To go from this top number to a number in scientific notation, what you're told is you want to move the decimal to make it a number between 1 and 10. In other words, if I put my decimal right there, 1.04 is a number between 1 and 10. So you wouldn't call it 10.4, you wouldn't call it 104, you wouldn't call it 0.104, you put it there. And then, like some of you might do in metric, I would just count how many places I've moved. 1, 2, 3, 4, 5, 6. Which means this would be the same as 1.04 times 10 to the negative 6th. When it is a tiny number, it's a negative power of 10. The zeros are in front. 5 zeros in front of that. The second one is a big number. Now granted, there is no decimal right now, but we know it's at the end of that problem. And if we were to put a decimal to make this a number between 1 and 10, we'd put it right after the 7. 7.342. So how many times do I move my decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Seven 7.342 times 10 to the 9. My hope is that makes sense to you. My goal today was not to explain scientific notation. I hope that someone has done that for you in the past. If not, I apologize, because I'm going to move past this right now into something that we have to make sure you have to do. So again, my hope is that looks familiar to you. Because when I look back at our goal sheet, yes, you should understand how to go from standard notation to scientific and back. But more importantly is the calculator parts on the bottom. We are trying to prepare you for all the types of math that we're going to be doing this year. That's why we had to do conversions today. That's why we're doing powers of 10 today. Calculator error is a common thing that comes up. So we're going to prove that to you. In the middle of the page, it gives you a problem. It says 7.234 times 10 to the 25th divided by 1.72 times 10 to the 22nd. I want you to take a minute right now with your calculator, type that in, solve that problem. Type it in as written. If you typed it in as written, you would have had a long-winded number. I just rounded it off at whatever point. If you looked at the far right-hand side of your calculator, it would have said 47, as in it's to the 47th power. However, this is not the correct answer to this, because when you start working with numbers in scientific notation, you have to type it in properly. And what I mean by that is if we took 10 to the 25th and divided it by 10 to the 22nd, again, the big parts of both those values, that would give us 10 to the 3rd, not 10 to the 47th. what your calculator will do is obey by order of operations. It took these two numbers and multiplied them. It divided by 1.72, and then it stopped. And it got you an answer. And then it multiplied by 10 to the 22nd. Now, when I was over here, I first looked at James's calculator to see, okay, show me that wrong answer. But James didn't have the wrong answer. He had the right answer that was just 4,205.8, blah, 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 blah. Because what James did is he put all of this in parentheses, and then this in parentheses. And really that second set of parentheses was the important thing to do. Because if you remember order of operations, which again, not my goal to teach you order of operations today, but if I need to, I will individually. When you put into parentheses, now you're saying all this sticks together. Ladies and gentlemen, not only do I talk fast, I like to type fast. There's a faster way than doing parentheses. Look at your calculator. Okay? I want you to get on your own clean line, and I want you to type in exactly what I tell you to do. 7.234. Then, see that second function in the upper left-hand corner? Push that. And push right above the number 7, there's a comma, but the second function is EE. Do we have that? So now your calculator says 7.234E, type in 25. Divided by 1.72. Let's again do that EE button. Second, right above the 7, 22. Equals 4,205.8, blah, 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 right? That EE button means times 10 to the whatever power, and it puts it in parentheses for you. It's about 4 less buttons that you have to type every single time, and it avoids order of operation issues. So that might be something that you want to do. However, if you prefer parentheses because you're more comfortable with that, great. Do what will get you to the correct answer. Because again, we are moving into numbers that are huge that you cannot just do in your head. So I'm not going to read all of the above here, but when this was created, it showed you a whole bunch of metric prefixes and the examples of that equality with meters. Now, some of you actually had this worksheet out when you were doing stuff before. The bottom half of this worksheet shows you all of these different equalities. Are you ready for me to make life a little bit easier for you? You should know this one. Kilometer to meter, that's a very common conversion. You should be able to do that. Centimeter to meter, you should know that one. Millimeter to meter, you should know that one. And the last one that we really haven't touched upon yet, but you have to start to get used to, the nanometer. Micrometer is what the one in between those two is. Micrometer is a common unit of measure. Micro is a good prefix. Picometer is one that we will reference in the next unit, but we don't have to do conversions with. Good news for you. Mass, you should know kilogram to gram. And you should know milligram to gram. Otherwise, those prefixes typically aren't used. A picogram, boy, that'd be a ridiculously small mass of something. And quite honestly, ladies and gentlemen, there's only one that we truly use often in this class for volume, milliliter to liter. I'm not saying that we can't assess you on other options or even on a worksheet, but these are the ones that hopefully you're more comfortable with. So, if you flip to the back side of this worksheet,